Hi class. So in this video, we're gonna start talking about chapter 5 and 6, time value of money and discounted cash flow valuation, class 1. So before watching this video, you can download the notes for this chapter 5 and 6 class 1 from Canvas, and you should be able to see both a document in Word and another document in PDF. So if you open the document in Word, you can see that the words are clearer, but this document is the original document. You could read through and there will be questions for you to think about, and there's no solution field in this document. So you could first look at this document, and if you come across a question or example, you can try to solve the question yourself, and then go to the, after you finish the question, fill in the blanks here on the Word document, you can go to the PDF notes here, where I have more things filled in this document. You can see that besides the same contents as the Word document, I also add some of my handwritten notes here, as well as my handwritten solutions for some of the questions. Okay, so this one is more complete. This version in PDF is more complete, and it includes all the solutions for the examples and practices in the notes. However, I recommend you start with the Word document, so whenever you see a question, you could work on it by yourself first. Also, the words here are more clear. Okay, so let's start from the Word documents. You can see that in our first class, on the first page, I am summarizing the key points and key formulas we're going to cover in the first class here. The key concepts we're going to learn are 4 types of cash flows, including lump sum, ordinary annuity, annuity due, and uneven cash flow. Okay, these are 4 types of cash flows we're going to cover in first class. And then we're going to introduce the concept of future value and present value. Okay, in the second class, for chapter 5 and 6, we're going to learn how to calculate present value and future value for lump sum and annuities. Okay. And the key formulas for this first class is to calculate future value of a lump sum and present value of a lump sum. Okay, here shows us the formula, and we will also learn the financial calculator procedures as well. Okay, the first type of cash flow is a lump sum. It's a single payment made at a particular time. Okay, this is the most basic format of cash flow. Any type of single payment can be called lump sum. It could be a cash outflow or a cash inflow. It is as long as it's a single payment. For example, if you purchase a cup of coffee from Starbucks today and you paid, say, $5, that's going to be a lump sum. Okay, that's a one-time expense. Another example could be that if you receive, say, $100 from your parents today, okay, that's going to be a one-time income for you, right? That's going to be a cash inflow for you. That can also be called lump sum. Okay, the second type of cash flow is ordinary annuity. It is a series of equal payments at the end of fixed intervals for specified number of periods. Okay, there are 3 criteria or three key points to tell if it's an ordinary annuity or not. First, it has to be equal payments. Second, it has to be at the end of each period, for example, at the end of each month, quarter, or each year. Third, it has to be fixed intervals, such as each month, quarter, or year. Okay, so after reading the concepts for or definition for the ordinary annuity, can you think of any example in life that's an ordinary annuity? Okay, you can bring up an example in our discussion board if you think of any. But here, I'm gonna introduce a financial example. Okay, for example, if a bond has an $80 coupon payment that is paid at the end of every 6-month period until the bond matures, this $80 coupon payment can be called ordinary annuity because all the payments are in the same amount, $80. The payments are made at the end of each period, okay, every 6-month period. Third, it's fixed intervals, every 6 months. Okay, so all these payments, we can call it an ordinary annuity. Okay, for me, a life example for me as an ordinary annuity is that I actually receive my paychecks at the end of every 2 weeks. Okay, and it's a regular amount. Is this an ordinary annuity? Yes, it should be, right? If all my paychecks are in the same amounts, and if I'm receiving them at the end of every 2 weeks at these regular intervals, then my paychecks could be ordinary annuity for me. Okay, again, this is my life example. If you can think of any of your life example about what is ordinary annuity, please feel free to bring the example up in our discussion board for this class. Okay, so that's ordinary annuity. We have a sister concept with ordinary annuity, which is annuity due. Annuity due is a series of equal payments at the beginning of fixed intervals for a specified number of periods. There are 3 key points or criteria to tell if it's annuity due or not. Okay, 2 of the 3 criteria are the same as ordinary annuity. Annuity due and ordinary annuity, they are both of a series of equal payments. And they're both at fixed intervals, such as each month, each quarter, or each year. Okay, but the only difference between ordinary annuity and annuity due is that annuity due occurs at the beginning of each period. For example, at the beginning of each month, each quarter, or each year. Whereas ordinary annuity occurs at the end of each period. Okay, so out of the 3 criteria, ordinary annuity and annuity due share 2 same criteria. Okay, and the only difference between them is whether they occur at the end of each period or in the beginning. If it's at the end, it's ordinary annuity. If it's in the beginning, it's annuity due. Okay, can you think of any example in your life as annuity due? Again, if you can think of any annuity due, you can bring this example in our discussion board. Okay, a typical example you could think about is whether your rent, mortgage, or car loan payments are annuity dues. Okay, think about your obligations in life like these. If they are required to be paid off at the beginning of each billing cycle at fixed amounts, fixed intervals, they should be called annuity due. Okay, for example, for me, I'm actually renting an apartment in Beechwood, Ohio. I need to pay for my rent in the beginning of each month. Okay, I pay about well, I'm not gonna tell you my rent, but I do pay my rent in the beginning of each month at a fixed amount at fixed intervals, and this can be called annuity due. Okay, let me know what annuity due you have in your life as an example, and tell me in the discussion board, please. Another financial example is that expenses for insurance are typically annuities due as the payment is required at the start of each period in which the individual or business is covered. Annuity due situations also typically arise relating to savings for retirement or putting money aside for a specific purpose. Okay, for example, if you're purchasing an insurance that requires you put a certain amount of fixed amount into your accounts at the beginning of each month, then that could be annuity due. Or if you have a retirement fund and you plan to put, say, $2,000 every month into the account for 30 years, that could also be annuity due. Okay, feel free to tell me any life example or financial examples about ordinary annuity and annuity due in our discussion board. And always remember, if the payments occur at the beginning of each period, it is annuity due. If it occurs at the end of each period, it is ordinary annuity. Okay, let's go to the fourth type of cash flow. Besides lump sum, ordinary annuity, and annuity due, we also have the fourth type of cash flow, which is called uneven cash flow. It is a series of unequal payments made over a given period of time. Okay, I could say that anything that doesn't fall into the category of lump sum or ordinary annuity or annuity due, we can basically say it's an uneven cash flow. Okay, it's not of equal amounts, it's not at fixed intervals, and it doesn't necessarily to be occurring at the end of or beginning of each period. Okay, the timing could be random, the amount could be random. So any other cash flows could be called uneven cash flow. Okay, and again, you can bring up examples on the discussion board. But for me, say a life example could be that my parents' money gifts. Okay, so sometimes my parents are happy. They would give me, say, several $100s as a Christmas gift, or at my birthday, they could also give me a gift card of a certain worth a certain value. So that could be an uneven cash flow for me, right? So each time I could be receiving different amount of money from my parents, and for each time it could be different amounts, okay, depending on how they feel, right? So it's random amount, random timing, and this could be an uneven cash inflow for myself. Okay, a financial example here could be that an index-linked bond with cash flows tied to the changes in CPI. Suppose that after its issuance, the bond pays $100 in interest. In the following year, however, if the CPI rose by a given percentage rate, then the interest payment would rise accordingly. For example, if the CPI rises 5%, it may rise to $100.05. If the CPI drops 5%, it may drop to 55% USD. Okay, so this index-linked bond pays interest according to how CPI is doing. Okay, first year you get $100, but for the second year, you could get more or less depending on if the CPI is higher or lower. So you have unequal payments each time. So this could be an uneven cash flow. Okay, so far we've talked about 4 types of cash flow. Lump sum, which is a single payment. Ordinary annuity, which is a series of equal payments that occurs at the end of each period at fixed intervals. Annuity due, which is a series of equal payments in the beginning of each period at fixed intervals. Uneven cash flow, any other cash flows that are of unequal payments or uneven timing. Okay, so these are the 4 types of cash flows. In order to show graphically better about these cash flows, we have a financial tool called Timeline to show the details of these cash flows. Okay, so here is an example of the timeline. We can see that here we have equal intervals for 1, 2, 3 time periods. We have tick marks that occur at the end of each period. Okay, we can see time 0, 1, 2, 3. Time 0 means today or the beginning of the first period. Time 1 means the end of each period. Time 2 means the end of the second period or the beginning of the third period. Time 3 means the end of the third period or the beginning of the fourth period. Okay, and then we have cash flows shown below the timeline. We have the timing, amount, and the sign for the cash flow showing if it's an inflow or outflow. Okay, let me pull the PDF version of our notes here so you can see better of my notes. Okay, for example, I'm marking here that cash flow 0 is negative 100 and cash flow 1 is 110 positive. It means that you have a cash outflow of $100 today, but we'll have a cash inflow of 110 at the end of the first year. Okay, that's how we mark the cash flows. And we can also mark compound interest rate per period above the first interval. Here we can see I% here. If the interest rate is 10%, we can also mark 10% here. Okay, so that we can use the cash inflow we have at time 0, $100, multiplied by 1 plus 10% interest rate, which equals 110. This is the amount we're getting after a year. Okay, so in this example, the interest amount we earned, INT, could be calculated by using the beginning amounts multiplied by the interest rate. So if we have a beginning amount of $100 and the interest rate is 10%, then the interest we're getting, INT, would be this $100 multiplied by 10%, which is $10 as our interest. Okay, so the amount we get after a year is 100 principal plus the $10 interest, which is 110. Okay, we can also calculate this 110 by using 100 multiplied by 1 plus 10%, which is 110. Okay, so this is timeline, and on the timeline we can mark the timing 0, 1, 2, 3, cash flow 0, 1, 2, 3, mark the interest rate, and we can graphically see how much we're paying today and how much we're getting after a year. All right, next topic. Let's look at simple interest versus compound interest. Okay, in the last example, we used compound interest, where interest payments are calculated on the principal and also on the accumulated interest of previous periods. So we earn not interest on principal, but also interest on interest. If it's simple interest rate, it is calculated only on the principal amount of a loan, not interest on interest. Okay, so in our real life now, most financial institutions are using compound interest rates rather than simple interest rates. Okay, for example, if we have $100 today and we're using simple interest rate, okay, after a year, we would get $100 plus $10, 100 multiplied by 10%, simple interest rate, So after a year, we get 110. But after 2 years, because we only earn interest on the principal, so in the second year, the interest we earn is $100 multiplied by 10%. So it's $10. So after 2 years, you would have $120 if you're using 10% simple interest rate. You can also calculate this by using the principal $100 multiplied by 1 plus 2 multiplied by 10%, which is 20%. Okay, so you have principal today of $100. After a year, you get interest as $10. In the second year, you get another interest of $10. So after 2 years, you have 120 in total because you only have your interest earned on your principal, which is 10% of the principal each year accumulated. However, if you're using compound interest rate, you not only earn interest on principal, but also earn interest on interest. Okay, after the first year, still you have principal of $100. If you have 10% compound interest rate, after a year you get 110. Okay, but however, in the second year, you should use this 110, the ending balance in the first year, multiplied by 1 plus 10%. So you have 121 after 2 years as your principal plus interest. Okay, because you are earning interest on the principal and also on the interest. So after 2 years, you can also use 100 multiplied by 1 plus 10% square, which is 121 as what you will be getting after 2 years if the principal is 100 and the interest rate is compound interest rate as 10%. Okay, so you can see that using compound interest rate, we're getting 121 after 2 years, where if you're using simple interest rate, you only have 120. So we earn $1 more if we're using compound interest. Okay, and this one additional $1 comes from the interest in the second year based on the interest we earned in the first year of the $10 in the first year. Okay, so $10 multiplied by 10% is how we get this one additional dollar that we earn using compound interest rate. Okay, so this is simple interest rate and compound interest rate. And throughout our course, we will be using compound interest rate. Okay, now let's look at the concept of future value and present value, and let's use compound interest rate to compute future value or present value of a lump sum. Okay, question. If you have two options to earn $100 now or $100 1 year later, which one do you prefer to get? You can get deposits $100 in the bank and get risk-free interest rate today. So after a year, you get 110 if interest rate is 10%. You want to get the same amount of money as early as possible. $100 today is worth more than $100 in the future. Okay, so here is telling us theoretically, you want your money as early as possible because of the time value of money. Even though it's both $100, $100 today is worth more than $100 after a year. Okay, if you get the $100 today, you could deposit in the bank and get interest rate. So after a year, you could have earned more, okay, because of this risk-free interest. Money has time value, and we would like to get the money as early as possible. Okay, so if $100 today is actually worth 110 after a year because the risk-free rate is 10%, we say that this $100 is the present value of the 110. Okay, and we say that this 110 is the future value of this $100. Okay, this present value is worth the same as the future value, even though they're of different amount, but because money today is worth more than in the future, so they are actually equivalent in the financial concept. And the process of going from the future value 110 from present value $100, we say this is compounding. Okay, when we use $100 multiplied by 1 plus 10% equals 110. When we get this future value of 110 from the present value of $100, we say we're compounding. And the reverse process of going to present value from future value is called discounting. So if we know the future value is 110 and we divide by 1 plus 10% to get this present value as $100, we say this is the process of discounting. Okay, we use present value to compound to get future value, and we use future value to discount to get present value. Okay, so this is the concept of compounding and discounting. And let's look at an example of solving for future value for a lump sum. What is the future value of an initial $100 after 3 years if interest rate is 10% as the compound interest rate? Okay, so step by step, if we can solve these questions by using step-by-step method, by using formula, and by using financial calculator. So let's look at the step-by-step method first. Okay, we have $100 to start with at time 0. After a year, future value at time 1 will be this $100 multiplied by 1 plus interest rate 10%. So it becomes $100 multiplied by 1.1. So we have 110 at the end of the first year. And then in the second year, we can use this 110 multiplied by 1 plus 10%. So we get 121. Alternatively, we can just use the original $100 multiplied by 1 plus 10% twice. Okay, so we have 1.1 square. So we have this 121. After the third year, we have future value 3 as present value multiplied by 1 plus 10% cube. Okay, so we have $100 multiplied by 1.1 cube. So we have 133.1 after 3 years. Okay, so this is how we work on this problem step by step. But from this method, we can notice the pattern that the future value at time n is just present value multiplied by 1 plus interest rate to the power of n. Okay, so in this question, we can just use the formula here because we know present value is 100. We know I interest rate is 10%. We know n is 3. So we can just use the formula that future value at time 3, which means the future value at the end of the third year is the present value 100 multiplied by 1 plus interest rate 10% cube or to the power of 3. So we have 133.1 after 3 years. Okay, so this is the formula for future value of a lump sum. Another way to work on this question is to use our financial calculator. Okay, so please bring or take out your financial calculator. Okay, it should look like what I'm showing here on the screen. Okay, you should turn on your financial calculator, and if you only see 2 decimals on your calculator, I recommend you to press second here and then press format, which is the same button as dot. Okay, and you can see that on the screen it says DEC decimal. You probably see number 2 on your screen, and you could press 4, enter. Okay, enter button is here to make it 4. Okay, and then you press second, quit. So you can see 4 decimals on your screen, and I recommend you to have 4 decimals all the time for our homeworks and exams. Okay, let's solve this question now. The buttons we're going to use will be on the third row here. Okay, this is called TVM worksheet on the BA2 Plus Texas Instruments financial calculator. You can see that we have N, number of periods, I, interest rate, PV, present value, payments, which usually refers to annuity amount, and FV, future value here in this worksheet. Okay, we're gonna input the variables we know and compute for the value we're looking for. In this question, we have a lump sum, and we know it's $100 today as our present value. So let's input 100. Okay, we input numbers first, and then press PV. Okay, here you can make 100 either negative or positive. If you make it negative, it means cash outflow. If you make it positive, it means cash inflow. Okay, let's pretend we're just depositing $100 to the bank, which means we have this cash outflow of $100 today. So let me make it negative by pressing the negative sign here. Okay, and then I press PV sign here. You should see on your screen that present value PV equals negative 100. You could also see a triangle here, meaning the value is successfully input. Okay, so now the calculator knows that we have a present value that is a cash outflow of $100 today. Okay, then I need to input 3 as our number of years. So I put 3 as N, 3 years. And then it's 10, because our interest rate is 10%. And the calculator will add the percentage sign automatically. So you just need to input 10 and then press I. So the calculator knows that the interest rate, I/Y, interest rate per year or per period, is 10%. Okay, and let's make sure the payment is 0 here. We don't have an annuity here yet. So we make sure 0 as payments. And then we can press compute sign here. Compute FV, compute future value. The screen shows future value equals 133.1. Okay, the calculator uses the formula and calculates for you that the future value of $100 today after 3 years with the interest rate of 10% is 133.1. Okay, please try these procedures in your own financial calculator and get familiar with it. If you're not sure what to do, you can always rewatch the video or you can read our notes here. All the procedures are listed here. Press 3 and 10I, negative 100 PV, 0 payment, compute FV. You'll see future value equals plus or positive 133.1. Okay, there are 2 things here for us to note. The first thing is that for a calculator, the signs of future value and present value can be switched, but they should always be opposite. Okay, so if different, and they would mean different meaning in life. What we just did is that we input negative 100 as PV, and the screen shows us positive 133.1 future value. So this means we're having a cash outflow of $100 today, and we're having a cash inflow of 133.1 3 years later. Okay, such as we're depositing $100 today in the bank and we withdraw after 3 years. So we are paying $100 today and receive 133.1 after 3 years. You can also input present value as positive 100, meaning a cash flow inflow of 100. In that case, the screen will show negative 133.1 when you compute for FV. And that means cash outflow 3 years later, such as you are borrowing $100 from bank today. That's why you have this cash inflow today. And then you're paying back 133.1 in the future. Okay, so let me show you on this financial calculator here. If I change my PV into $100 positive, okay, I press 100 and I press PV. And then now if I compute for future value with all the other variables stay the same, you're going to see a negative 133.1 here, meaning because I get $100 today, I have to pay back 133.1 after 3 years. Okay, this is no free lunch rule. PV and FV here, if we don't have any annuity involved, we're just looking for the present value or future value of a lump sum. PV and FV here, they should be of opposite signs. If you want to get something today, you have to pay it back tomorrow. If you pay something today, you will get reimbursed in the future. Okay, no free lunch rule. Another thing to note here is that for the calculator, you just input 10 instead of 10% for interest rate I. The percentage sign is by default. Okay, remember we input just 10 as I, not 10%. All right, let's look at another example here. What is the present value of $100 due in 3 years if interest rate is 10%? Okay, so we have the same interest rate, same N. We are looking for the present value of this lump sum $100 now. So the formula is reversed because future value at time N is present value multiplied by 1 plus I to the power of N. If we're looking for present value here instead of future value, so we can just use future value N divide by 1 plus I to the power of N, so we can get PV. Okay, in this case, future value is $100, interest rate is 10%, N is 3, so we can just use 100 divided by 1 plus 10% cube, which is 75.13. Okay, if we want to use the financial calculator, we can input 3 as N still, 10 as I still. Now we know the payment is still 0, and the future value is $100. And then compute for PV. Okay, you see negative 75.13. Okay, if we want to receive $100 after 3 years, we have to depositing or paying 75.13 today. Okay, so this is how we work on present value or future value of a lump sum. If you want more practice, you could go to our homework, and I believe the first few questions in our homework 1 is about present value and future value of a lump sum. Other financial calculator procedures. What if we're solving for I, interest rate? What annual interest rate would cause $100 to grow into 125.97 in 3 years? Okay, here it's hard for us to solve for interest rate here using the formula, so let's just use the calculator. Okay, so we can still input 3 as N because we have 3 years, and our present value is $100. Our future value is 125.97, and again, we have to make these two opposite signs. So let me make present value negative sign. Okay, we're looking for I, so we're going to compute it later. Payment is still 0. Future value is 125.97 as our future value. Okay, and then I compute for I. Okay, we see 7.9997%. Okay, remember to add back the percentage sign. When I is 7.9, it actually means we have an interest rate of 8%. Okay, next question. What if we're solving for N? If sales grow at 20% per year, how long before sales double? So we know the interest rate is 20. We can input 20 as I. Okay, we want to solve for N. Now we don't know PV or FV, but we know that future value is double of the amount of present value. Okay, so we can assume any number here. For PV, we can assume it's -1. Okay. For payments, it's still 0. For future value, it should increase to +2. Okay, you can also make present value negative 100. Then your future value should be 200. Okay, future value and present value here in this question, they should be opposite signs. Also, future value amount should be double of what present value amount is. Okay, and then we compute for n. Okay, we see 3.8 years. It takes 3.8 years for the sales to be doubled. If the sales today is 1, it takes 3.8 years for it to become 2. If the growth rate, here is the growth rate as 20%, similar to the interest rate. Okay, if the sales today is $100, it's gonna grow to $200 after 3.8 years if the growth rate is 20%. Okay, so that's the future value of lump sum, present value of lump sum, solving for I, solving for n questions. For all the 4 questions, you can use these 5 buttons here in the 3rd row of the calculator to solve. You can also go to our homework, again, homework 1 for questions about solving for PV, FV for lump sum, and solving for I or N to practice with these 5 buttons here. All right. I would like to introduce you a little bit more of the financial calculator functions. Again, we can change decimal. Okay, here I'm showing this on the notes as well, that we can change decimal by pressing second format. Okay, and we can input decimal required, for example, 4, enter, second quit. Okay, so we can set the decimal as 4 decimals. By default, if you reset your calculator, by default your decimal is 2 if it's brand new. Okay, other default setting, the P/Y, the payments per year is set as 1. Compounding period per year, C/Y, is set as 1. And we're also in the end mode. Okay, we'll discuss more about these settings and how to change them in the future classes. If we want to clear the TVM worksheet values, meaning clearing the value inputs for these 5 buttons, we can press second, clear TVM, second quit. Okay, delete an entry. If you input 45, you want to delete the last entry, you can press this button here. Okay, so it's deleted. Clear everything. If you want to reset your financial calculator like new, brand new, by and making all the settings by default, then you press second, reset. Okay, here's the button here, the same as the negative sign. Okay, and then you press enter as the screen instructs you. Okay, second quit. Now my calculator here is as brand new. You can see my decimal is back to 2. And all my value inputs are cleared. All my settings are cleared. Okay, sometimes you keep getting error on your screen and you cannot get any answer for the question. Sometimes it's because you change the settings and you have no idea what you did to your calculator. You could always second reset, enter, second quit your calculator to make it brand new and then rework on the problem again if error occurs repeatedly. Okay, here, but always remember, after you reset the calculator, change the decimal by pressing second format, 4, enter, second quit. Okay, so now your decimal is back to 4 and you can start to work on the questions in our notes and in our homeworks again. Okay, you can always go to our Word document, which is blank, to fill in the blank, okay, to test if you have known or if you are able to solve for these questions by using formula and calculator yourself. Okay, you can also go to our Canvas Connect page to work on our first homework. You should also find more practice problems in our textbook in the end of the chapter 5 as well. Okay, so that's our first class for chapter 5 and 6. In the next lecture, we're going to discuss more about how to calculate present value and future value for annuities.